I've had someone ask me about this particular worksheet and what they're asking for, so let's go through it a little bit. It's called the Very Bad Ideal Gas Worksheet. It's kind of a tongue-in-cheek way of looking at the gas laws. So you'll need your periodic table, of course, and a calculator. If you don't have a calculator at home, please go on to the site, or if you know how to find Desmos, there's always one there. So it says, I'm considering remodeling my house and I have a 55-liter tank of nitrogen in my shed. So I have a volume of 55 liters. This tank contains 15 kilograms of nitrogen gas. So it has a mass of 1,500 kilograms. I'm going to change that to grams right away because I know how to work with that much better. And it can withstand a pressure of 150 atmospheres before exploding. So, can stand 150 atmospheres. So if I was to accidentally heat this tank to a temperature of 815 degrees Celsius, so my temperature is 815, and to turn it into Kelvin, I would add 273, because remember, all gas laws need to have temperature in Kelvin. I'm going to get a total of 1,088 Kelvin. So now it says the ideal gas law. Remember, the ideal gas law is PV equals nRT. Because I'm working with atmospheres, my R is going to be 0.0821. Now this N represents moles. So I have 15,000 grams. So I have to go from grams to moles. To find that out, I would take my 15,000 grams of nitrogen gas, which is N2, because remember it's diatonic. 5 grams here, I must have grams here. So this is where my handy dandy periodic table comes into play. And I find out that 2 times 14.00 helps turn it on. 2 times 14.0067 is equal to 28.0134 grams, and that's 1 mole. And I go on my handy dandy calculator, divided by 28.0134, and I get 535.46 moles. And I'm not going to be so concerned with significant digits right now, as I am about just making sure I am kind of figuring out this answer. And when I'm all done, I'll figure out how many significant digits I need to use. So I plug this in my PV equals nRT. What I'm really looking for is that pressure. It says here, would this tank explode and save me the demolition cost of my coming addition? I'm looking for the pressure. It can withstand 150. So I'm going to be looking at that pressure. So the pressure is what I'm looking for. That's my unknown. My volume is 55 liters. My N, I just figured that out, is 535.46. R, 0.0821. My temperature is 1,088. So I plug that all in my calculator. I take that number 535.46 times my R times my temperature divided by my volume, and I end up with a pressure of 869.63 blah 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 atmospheres. In significant digits, that would be 870 atmospheres, which is substantially above the 150. So realistically, if I was to accidentally heat that tank to a temperature of 815 degrees, it would not only explode, but I would need to stand a long distance away from it. I hope this helps. That's the type of questions that will be the last 2 on this worksheet. Have fun with them.